Hi and Assalamualaikum everyone. In this video, we will present about the introductions of radiation detections and the instrument used to detect the radiation. But first, let us introduce ourselves. My name is Siti Nur Ain and this is my teammates, Siti Najiha and Sharifah Noliana. Let's begin. Radiation is defined as the emission of energy as electromagnetic wave or as moving subatomic particles that cause ionization. Ionizing radiation is harmful and can cause chemical changes in cells. Ionizing radiation cannot be detected by human senses, so suitable instruments are required to detect and measure them. All methods of detection of ionizing radiation are based on the ability of such radiation to cause the ionization either directly or indirectly. There are about 4 types of radiation instruments such as portable radiation monitor, area radiation monitor, personal dosimeter, and monitor for internal radiation contamination. This instrument is used to detect the radiation. Now, let's dig into it. For portable radiation monitor, this instrument operates with the aid of battery and can be held by hand because the size is quite small. For example, Geiger counter and scintillation counter. This radiation detection usually used at radiation facility to ensure that the radiation level is within the limits. Portable radiation monitor must be calibrated at periodic interval in radiation calibration facility. Portable radiation monitor consists of probe and associated electronic circuit. The probe contains detectors such as Geiger molar tubes. Now, let's see how it works. Geiger molar tube component involve Dimica window, central wire as anode, metal tube as cathode, metal, power supplies, and low pressure gas such as argon. The detection process begins when the radiation enters the tube through the Dimica window. The radiation then collides with the gas molecule in the tube and causes ionization, where the formation of positive ion and electron occur. The positive ion will attract to the metal tube, while the electron will attract to the central wire. The electron then travel down to this wire, making a burst of current in the circuit that connects to it. The electron flow make the meter needle deflect to show the radiation presence. Before the counter can detect any more radiation, it needs to be restored to its original state, where the electron will flow to the metal tubes and neutralize it. That's how this instrument works.
Next is area radiation monitors. The picture shows a few examples of area radiation monitors. Area radiation monitor is designed to give an indicator of the external radiation level present in an area where ionizing radiation are present. This monitoring system usually designed to detect gamma radiation. In some of the monitor, it can sound an alarm if the level of radiation exceeds a certain value. The third type of radiation instrument is personal dosimeters. There are 3 types of personal dosimeters. The first one is thermoluminescent dosimeter batch, or also known as TLD batch. The second one is quartz fiber electroscope dosimeter, or also known as Qfe Dossimeter, and the third personal dosimeter is called Beeper. Personal dosimeter is used to determine the amount of radiation received by a radiation worker in the course of his or her work. Now, let's take a look on TLD batch. TLD batch consists of 2 lithium fluoride chips that mounted on a card and encased in a special holder. Lithium fluoride is used because It can store energy during exposure of ionizing radiation and subsequently release it as visible light when it is heated. The LD badge is worn like a metric card on the body of the worker for 1 or 2 months, depending on the nature of work. Throughout the time, the amount of radiation which the worker received is recorded on the TLD chip. After that, the used card is exchanged for a new one. The second personal dosimeter is Qfe Dossimeter. It usually used by the workers who work in non-destructive testing occupation. Qfe Dossimeter has a shape of a pen and contains a quartz electroscope in a small ionization chamber. It also provided with an optical system. One of the advantages of Qfe Dossimeter is it can give an immediate reading of the radiation dose received by the wearer. However, Qfe dosimeter are less accurate than other personal dosimeters, and it is easily affected by shock. The third personal dosimeter is beeper. Beeper use a conventional gigamolar tube and has LCD type display to display dose rate. It uses battery as power supply to function. Like its name, the beeper will produce an audible beep sound as warning when the radiation dose exceeds a certain value. However, the reading of the beeper can vanish if the power supply gets disconnected.
Explain how personal dosimeter works for TLD page, Qfe dosimeter and beeper. For TLD badge storing the energy that they receive from the ionizing radiation. For the workers that work at a place that is exposed to the radiation, they will wear and using TLD badge to record the amount of radiation that have been exposed. TLD badge will receive and store the amount of radiation on the TLD chips. Next, the used card will be heated up to the high temperature using TLD reader. On the heating, the absorbing energy is released in the form of visible light. Lastly, a plot of light intensity emitted against the temperature known as a glow curve. Next is Qfe Dossimeter. Qfe Dossimeter using by workers that involved in the non-destructive testing work. Qfe contains a quartz electroscope in the small ionization chamber. How to read Qfe Dossimeter? Qfe Dossimeter can be read through the scale that can be seen when point the dosimeter at the light source. Next is beeper. Beeper is a small instrument that carry in the pocket. Beeper produces an audible beep as a warning sound at a rate that depends on radiation level. When a predetermined dose rate is at 0, beeper will give a warning note which increases in frequency. Next, I will explain about internal exposure and external exposure. External exposure means that the body receives radiation that comes from radioactive materials from the external environment. Internal exposure is the radiation that emitted in the body. Instrument for measuring external exposure. GM counter survey meter has a thin entrance window and can detect beta particles efficiently. Ionizing chamber survey meter. An eye skin dilation survey is an accurate and very sensitive instrument. Personal dosimeter measures personal dose equivalent of the relevant personal exposure. Monitor for internal radiation contamination, stand-up whole body counter, chair whole body counter, scanning bed whole body counter, and tie rod monitor.